Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Today's show is brought to you by OnPay, the new standard in payroll. You can pay employees and contractors in minutes, automate your payroll taxes and filings, as well as provide health benefits and HR in all 50 states. For more information, visit buildingthefutureshow.com/onpay. Welcome back to the show. Today we have Bob Baxley. He's the Chief Technology Officer at Bastille. Bob, welcome to the show.
Hey, Kevin. Thanks for having me. Happy to be here.
Yeah, I'm excited to have you on the show. I think what you guys have been doing at Bastille is actually really innovative and cool. But maybe before we get into that, let's get to know you a little bit better and start off with where you grew up.
Sure. So I grew up mostly in Jacksonville, Florida.
Okay.
And then I came to Georgia Tech in 2000 to start my undergrad degree, and I've been in Atlanta ever since.
Okay. So what did you take at Georgia Institute of Technology, and why?
It's a good question. So I studied electrical engineering.
Okay.
I'm a little bit embarrassed to say, though, that although I have a PhD in electrical engineering now, you wouldn't trust me to wire your house. I moved more towards the algorithms and signal processing part of electrical engineering.
Interesting.
And that was a big emphasis at Georgia Tech, so I gravitated towards that. So it was closer to algorithm development, maybe even software engineering was what my expertise was in.
Interesting. So was there like a moment or something growing up that made you interested in electrical engineering, or walk us through that?
Sure. So I did early robot competitions in high school. I was
interesting.
Definitely not the geek, right?
No, it's all good.
Yeah, so there was a competition that's still going on today called Ball, and it was modeled off of a undergraduate course at MIT. MIT had made this little computer that was the size of a little bit thicker than a modern cell phone, but small enough that you could put in a Lego-based robot and control servos and motors and whatnot. So
that's cool.
Yeah, I did that competition where you make a robot. It had to be completely autonomous. There was no remote control. It would go pick up ping pong balls and move them around. So I was pretty into geeky computer stuff from early on. And yeah, I think that mix of liking hardware and software and programming, I thought electrical engineering would have the right mix for me. And I think I was right.
Very cool. So walk us through, obviously you got your PhD, but walk us through the rest of your education and your career up until Bastille.
Sure. So I studied at Tech, and I really liked school, really liked learning, and decided to go to graduate school. And I had a good connection with a professor there at Georgia Tech, Dr. Tong Jo. And she ended up inviting me to be in her research group for a master's program, and then just continued on to get a PhD.
Very cool.
So I was studying communication signal processing. So this is, what are the algorithms you use to decode communication signals? Specifically, my research was on trying to minimize the power consumption of cellular base stations. And one mechanism that causes power consumption to be high is if you have a signal that has lots of peaks in it, which may sound strange, but when your cell tower is transmitting a signal, that signal is oscillating up and down. And if it oscillates and has really high peaks, you need a more expensive and more power-hungry power amplifier to amplify that. So one way to mitigate that power consumption is to come up with a way to make the peaks lower without sacrificing communication performance. So ended up doing a lot of work in that area, and that got me really familiar with communication signals and All things related to wireless communications.
Interesting. So, okay. So you get out of school. Walk us through what you did out of school up until Bastille.
So I left Georgia Tech, and I actually joined the Georgia Tech Research Institute as a research faculty member. So that job was mostly executing research programs for government and DoD groups, also some commercial work, but lots of work in just kind of applied research of how do we improve our waveforms, how do we improve our jammers, how do we better detect signals. So, a lot of experience doing the research, selling the research, leading kind of teams to execute on research there. One of the interesting projects we did was called RadioBot, and this was putting software-defined radios on top of autonomous robots. I'm back to robots.
Cool.
The Roomba, the vacuum platform, iRobot makes a Roomba without a vacuum in it, which is pretty cool. It's only $100 and something.
Okay.
And you can program it. You can put a little computer on top of it and have it roam around according to whatever that computer is telling it to do. So one neat thing in kind of radio and spectrum research is being agile in the spectrum. So the names have changed over the years, but originally it was cognitive radio was one name it went by. And the idea is if you've got a really crowded spectrum, it's either crowded because there's lots of users or you've got adversarial users trying to jam you. It'd be nice if you could sense that activity and then move away from it spectrally. So if there's an emitter at a gigahertz, you might want to move to 1.2 gigahertz to avoid interference. An extension of that is, so that's moving spectrally. You could, though, move spatially. So if you imagine putting radios on drones and they're trying to execute some sort of radio frequency mission, be it communications or jamming or sensing, you may want to reconfigure them spatially so that you achieve the same effect. Maybe if you move over here, you put a mountain between you and the interferer. And so now you've done the same thing, but you didn't have to move in the spectrum, you moved spatially. So we built a test bed and platform with 8 robots and software-defined radios, so you could prove out spectrum and spatial agility, which is a pretty neat project.
Well, that's very cool. So
and, yeah.
Keep going. Sorry.
Oh, so that was one of the projects. Another project that kind of got me into Bastille was DARPA, which is a defense agency that funds research projects, low-level, kind of high-risk, high-payoff research projects. They occasionally have these challenge competitions. So the most famous one is the autonomous vehicle competition.
Right.
That ran in the early 2000s. And there, the objective was for a team to build a vehicle that could autonomously navigate across a 200-mile desert. And the first year they ran it, the furthest any car got was a mile or two. And there, all these big name teams were there, and nobody managed to do very well. And then the second time they ran it, almost all the cars got across the desert, and some of them at very high rates of speed. And this is like mid 2000s. And the winners of that competition went off to start the Google car projects at Google and the Uber car projects at Uber. So anyways, one of the challenges DARPA put out in 2014 was a spectrum challenge.
Okay.
Where they wanted to have teams design autonomous radio platforms, software-defined radio kind of payloads that would go on a DARPA software-defined radio. And the objective was for you to design a radio that would communicate with, you have a source and a sink. You wanted to push bits across your link, but you also had other competitors operating in the same space on the same frequency. So you had to simultaneously try to make it so they didn't transmit very well by jamming them, and you had to be robust against their interference and their jamming. And you had to do all that autonomously. So Georgia Tech, we had a team. I led the team, and we ended up getting second out of 90 teams.
Wow, that's actually really impressive.
Yeah, it was super exciting, and DARPA did a really great job of building this big infrastructure to run the competition. so yeah, so that was exciting. And through that work, I met all the other, it was a pretty close-knit community. So I got to meet all these other radio nerds who were really into software-defined radio. And so, yeah, shortly after that, a guy named Chris Ruland, who had a few successful exits, was thinking about starting a radio security company.
Yes, I actually had him on the show, so that's cool that that he recruited you. That's cool.
Yeah, so Chris had just started Bastille, and he asked me to join him. So started it, and I actually joined, and then I went and hired the first place, third place, and fourth place people from each of those teams from the
Smart, right?
So, I got a little bit of revenge on my buddy Roy, who beat me in the challenge, because I was able to hire him to Bastille.
That's funny.
So that was a great close-knit group of people really passionate about software-defined radio that formed the core engineering team at Bastille. So we were able to move really fast building this software-defined radio capability that we've got.
Very cool. So for people that haven't heard of Bastille, what exactly do you guys do?
Great question. So let me frame it a few ways.
Okay.
Let me paint a picture of what happens in IT security today, and then I'll tie Bastille into that.
Sure.
So today, if you have a computer, if you're in a big organization and you plug a computer into your Ethernet jack, there's IT security companies that have built products that will, one, tell you if that computer is authorized. Two, there'll be an agent on that computer, antivirus or something, so that IT security can manage the computer and make sure it's not doing malicious things. And then there's network security appliances that are monitoring the traffic to and from that computer to see if it's been compromised. Maybe it's now part of a botnet and it's doing a DDoS attack, or if data is being exfiltrated. So you get all this monitoring for wired networks and maybe even your corporate Wi-Fi networks. What is missing is all the monitoring for all the IoT devices, all the other networks in your space that aren't going through your kind of corporate modem out to the internet. So this is everything from cell phones to wearables, to building control systems, industrial control systems, IoT systems. So at Bastille, we've built sensors, these physical sensors that you deploy in your facility. They're monitoring all the radio frequency transmissions in this space. And we tell you about all these devices that are otherwise invisible to you. And we tell you about them because they may violate some device policy you have. You may want to manage all the devices in your space. And they may also represent an attack vector or an exfiltration vector. So at the high level, we build sensors, we deploy them to enterprises so that those enterprises can have a dashboard that tells them about all the radio frequency emitting devices in their facility. And the dashboard includes a map. So each emitter in their facility becomes a dot on their floor plan map. And then once they have that visibility, they can go decide what to do with these devices, whether they remove them, ensure that they have the right firmware, et cetera, et cetera.
Interesting. So, well, and I guess it probably depends on what people get, but is there a range on a sensor? Like if somebody's doing something malicious outside of your office building, can you guys pick that up as well?
Yeah, that's a great question. So the deployment model is you put a sensor every 50 feet or so. It's similar to how densely you deploy your Wi-Fi access points.
Okay.
And we do have a way, we are just about to release ruggedized sensors, so you could monitor your outdoor facilities as well. So we have both indoor and outdoor sensors, so you can cover in your perimeter and outside your perimeter.
Interesting.
Yeah.
Okay.
And so one of the things that people worry about is if you dig into what hackers, so that there's this really robust community of security researchers who are constantly looking at ways that systems have been poorly designed or have security vulnerabilities built into them. And one of the back in the 90s, that was injecting malformed packets into network infrastructure. There's still some of those vulnerabilities today, and that could let an attacker get remote code execution on a switch inside your facility. The analogous thing has happened over the last almost decade in the wireless space, where hackers and security researchers have realized that people who have designed these radio frequency interfaces, they didn't put a whole lot of thought into the security of them. And sometimes even if they did put a lot of thought, it's a hard problem and there's still security vulnerabilities. So some neat ones are, there's a group that came out with a pair of vulnerabilities called Bleeding Bit and Blueborn. So these are both Bluetooth and Bluetooth low energy vulnerabilities where, so imagine you have a Bluetooth device. It's kind of constantly listening to see if there's another Bluetooth device trying to talk to it. And in doing that listening, when it senses a packet, a Bluetooth packet, it will try to decode it with its decoding stack. So there's been those two vulnerabilities and others where people have shown if you send a malformed packet or if you construct a sequence of packets in a certain way, and the decoder stack has a bug in it or a corner case or allows for a buffer overflow, then the attacker, just by transmitting Bluetooth at this device, can compromise the device. They can maybe make it so it turns off. They could put it in a freeze state so it doesn't work, but it hasn't turned off or reset. And the Blueborn people even showed that they could get remote code execution. So they could send a certain sequence of packets to actually get the device to run code that they have, and now you've taken over the device.
Wow.
So, you know, if you want to protect against those things, the first step is just understand where Bluetooth is in your infrastructure, for instance.
Sure. So then, because like, obviously in your Bluetooth incident you're just mentioning, sometimes patching that stuff is a software update. Sometimes if it's a hardware problem, well, you're kind of screwed, right? Like how do you can't really patch hardware. But how do people leverage your technology? Okay, so like it notifies me there's an issue, then I need to figure out how I want to solve that. And obviously it depends on what the issue is, but how do I use your technology to solve that or help me solve that? Or is that outside of what you guys do?
Couple answers to that. So a lot of times you've got this rogue interface, and it's rogue is the wrong word. This interface you didn't know about in RF.
Right.
And you don't want it on, and you're actually able to turn it off. So one example was we were in a data center, and they had chillers in the data center to keep the air conditioners essentially.
Right.
And they were controlling the chiller over the Ethernet interface. But the manufacturer, the contractor who'd installed the chiller, had left Zigbee on. And so as soon as they turned on our sensors in the data center, we saw these two Zigbee emitters, unencrypted Zigbee emitters, waiting for a Zigbee controller to connect to them and control them. So we actually call that the radio ready problem. This infrastructure was designed for multiple users, and one of the people they built it for wanted to control it over Zigbee. This company didn't want to do that. Once they realized this, they just went and turned off the configuration for Zigbee. So there's lots of, I'd say the most common thing we see in enterprise is just misconfigured devices. Yeah. And misconfiguration is a known problem across all kinds of security realms. So that's pretty straightforward. As far as ripping out emitters, I mean, we kind of joke that that's hard, but we definitely have DoD customers who don't want emitters in their TVs. And so when they go buy a Samsung TV, before they put it on a wall, they open it up and they pull out the Bluetooth and Wi-Fi chip. And so those customers are using Bastille to make sure that that has been done and that nobody, changed the configuration so that if it wasn't a hardware disable, it was a software disable, that when you updated it, the software didn't get re-enabled and now you've got an emitter in your space again.
Right. No, that's interesting because, well, keep going. Sorry.
Well, one more example is there was a security research piece that Bastille released called Mousejack. And we found that over a dozen of the most popular USB dongle to wireless mouse and keyboard systems were vulnerable to keystroke injection. So,
interesting.
Yeah, so if you've got that, like a Logitech USB dongle and then Logitech mouse and keyboard, first of all, you might think that's Bluetooth. It's not Bluetooth. It's a proprietary protocol that Logitech invented. Same thing with the Amazon version and the Microsoft version. They've all created their own wireless protocol. which if you're a security person, you know that's not the best idea. You should use a standardized protocol. It's been vetted well. The protocols use encryption, but it turns out the bug was that if you send unencrypted packets to it, if you say, so if I type the letter K, it's an encrypted packet gets sent, but there's an unencrypted version of that packet that you can send to it, and it will still type K. So we were able to demonstrate that from a long way away, like 300 meters, you could inject keystrokes into a system. And if you can inject keystrokes, it's as good as being at the keyboard.
Wow.
So in that case, one of the banking customers installed Bastille, and they saw that they had many wireless devices, mice and keyboard with this vulnerability. They just junked them all and bought wired mice and keyboards for their sensitive area. So it does happen where, yeah, you're right. If you're just kind of screwed if you have the wrong hardware. And if you care enough about it, you'll just go replace the hardware.
Yeah, makes sense. Interesting. So, like, I think you can tell me if I'm wrong here. I think the biggest misconception is a lot of people, I think, don't care about security until it's too late, or they feel like they do a 1 or 2 or maybe time spend, and then that's it. And you constantly need to be on top of this stuff because, to your point, it's like, well, if you bought a new TV, well, it may or may not be hackable, right? If you buy a new mouse for somebody that's wireless, it may or may not be hackable. Like, we're doing stuff all the time that we don't even think about that could be a security hole. So security needs to be, I think, more important to a lot more companies than it is today. Do you agree with that, or what are your thoughts around that?
Well, I think you have to weigh the cost benefit. I mean, in my home, I'm not so worried about my TV getting hacked because the consequence is fairly low.
Sure.
If you're the DoD, you've got the consequences can be gigantic. So you really stay on top of your device security policy. Similarly, if you're a giant bank or hedge fund or technology company, or if really any big company and you've got a big data center, then yeah, you should probably go secure these really sensitive spaces. Maybe you're not securing your lobby, maybe you're not worried about less secure spaces, but certainly where board meetings happen or where data centers are, you should be more conscious of what's going on in those spaces.
I think that's actually really good advice, right? You're right. Because like, somebody hacks my TV at home, like, who cares, right? Like, okay, whatever. Like, you're not going to really get anything. It's probably more boring than anything. But yeah, you're right. If you hack like a TV in a boardroom where you're having like meetings about where you're taking the company or new features or whatever, it's probably important.
Yeah, exactly.
Yeah. Makes sense. So how do you guys stay current and ahead of kind of the bad hackers out there?
Well, so we're not necessarily in a hacker's arm race. Our key value add is that we provide you visibility of all the protocols. So we're kind of step one. You get Bastille, and we'll tell you where all these devices are. We'll give you information about the device. The kind of intrusion detection signatures, that's more of a specialized thing. Once you've found a device that may be vulnerable, there's more elbow grease involved in going and mitigating that vulnerability. So as far as we're concerned, we keep up with the literature, and we make sure that any protocols that have new vulnerabilities or known vulnerabilities, we have visibility into that, like the mouse and keyboard, for instance.
Sure.
So yeah, that's kind of the lay of land.
But
we do have a security research team that's looking at this stuff all the time, and picking at things and helping our customers understand the lay of the land.
But then I guess I should have said, like, but how do you make sure like your guys' sensors are like secure, I guess?
Oh, I see. Yeah, so one big way we do that is there's just security engineering. It's our DevSecOps process to make sure that we're rigorous with what kind of code we put on there. But another mechanism that's interesting about our sensors that keeps them more secure is that they're 100% passive.
Oh, okay.
So there's some RF systems out there that in order to find devices, they're having to probe for they're having to say who's out there. They're actively sending out RF signals. We found that a lot of our customers, they don't want another emitter in their space to help them find the existing emitters. So we put a lot of work into making sure we get the same visibility passively without having to transmit. And by being passive, we have better, the sensors are essentially covert. They go above your ceiling tiles, so they're not visible. And because they're not transmitting, they're not visible, so to speak, in the RF spectrum either. So an attacker wouldn't really know they're there.
Smart. Well, yeah, interesting. Yeah, no, that's interesting, right? And that's actually like a big selling feature for you guys.
Yeah, there was a lot of intellectual property that went into that. So one thing that our sensors do that's unique is, so if you have a hardware-defined radio, that is an ASIC chip for Bluetooth decoding, for instance. Bluetooth has 79 channels that it hops between. So every 600 microseconds, your phone and your Fitbit are hopping different channels in the 2.4 gigahertz range. And so if you don't have a software-defined radio, you probably just have one of these chips. And if you just have one chip, you're only seeing one channel at a time. So your devices are hopping into a different set of channels than my device. So you have limited visibility. And if you have limited visibility, one way to get around that is to just send out inquiry packets saying, who's there? In contrast, what we're able to do with our software radios is we can listen to all 79 channels simultaneously. So inside the sensor is this chip called an FPGA. A CPU is what's in your computer, and it's kind of parallel, on the order of 8 cores. GPUs are more parallel, graphics processing units, and then FPGAs are a couple orders of magnitude more parallel still. And they're what's used to process RF in real time usually. So we programmed these FPGAs to have 79 distinct Bluetooth decoders for all 79 channels. And that gives us this visibility that you don't have with other products, which means that we don't have to do the transmitting.
Okay, interesting. So how do you guys help if my company's actually under attack, like a DDoS attack or something? Like, can you detect it early, or how does that kind of work?
So we would detect, if you've deployed Bastille, we would detect if the DDoS attack has a wireless component to it. We would detect this huge increase in wireless activity. Similarly, if you've got a bad guy with physical access to your facility and they're scanning around your network they're basically doing the inquiry scanning to find all your RF devices, we would see that anomalous activity. Be able to alert you on it.
Okay, interesting. Do you want to maybe give us some other use cases or how people have deployed Bastille in their organizations? You've kind of mentioned a few, but I think just giving people some more examples of how people leverage your technology, I think would be useful.
Yeah. So we actually have 2 systems. Earlier this year, we released a portable version of Bastille. So Bastille Enterprise is the fixed system that you deploy in the ceiling tiles. You may put that in your data center to get constant visibility. But we've got customers in both DoD and Enterprise now buying the portable system, Bastille Flyaway Kit. And it's sensors in a Pelican case with a laptop and tripods. So we've got lots of customers. They don't necessarily need continuous visibility of all their space, but they would like to go audit spaces periodically to make sure that they don't have these rogue devices. So maybe they're not worried about intrusion. Maybe they consider that to be a long tail, unlikely attack, somebody trying to break into their system over Bluetooth. But just to have good security hygiene, they would like to not have any extraneous RF interfaces in their manufacturing facilities or like chemical processing facilities or office buildings. So we're selling a lot more of those to enterprise customers where they just want a flyaway kit. They've got security teams that already do audits for other things, physical audits in remote locations. And so they want to use a flyaway kit as part of that audit process and understand what's in their space. So they're looking for things like Zigbee on their chiller, if there's Bluetooth enabled on devices where it shouldn't be enabled. Even in medical settings, you don't want your MRI machine to have extraneous interfaces on. because there's no reason to expand that attack surface unless you're using that interface.
Interesting. No, I think that's actually really interesting. Any other examples of things to mention?
I that's most of the lay of the land. Yeah, I mean, in boardrooms and then in DoD, other RF devices like audio bugs are an issue, right? You don't want someone. You can go on to eBay, for instance, if you Google audio bug. If you're a creeper, you can go buy for $20 a cellular device that looks like a mouse or looks like a USB charger that's got a SIM card in it. And those devices are actually pretty neat. You call the number on the SIM card, and then there's just a set of typing in prompts to configure it so that when audio happens in that room, you can give it a number to call. And so you've basically got your own little stand-up audio conference room in a boardroom, for instance, and it can be an innocuous device like a charger. So if you have Bastille deployed, you'd see the existence of this cellular emitter in your space. Another one is also in data centers or in enterprise, people deploying shadow IT equipment or rogue IT equipment. So anybody who's been in a big company knows it can sometimes be a pain just to do simple IT things, like buy a computer, buy a server that you need for your job. So there's plenty of people out there who just avoid asking, right? They just buy their own.
Yeah.
And maybe they've got their own cellular modem, or maybe they've even gone and bought a cable modem to get outside access to that computer. So shadow IT ends up being a big problem in lots of IT departments. And so we've seen people who are using cellular modems to get that connectivity to whatever shadow IT equipment they've deployed.
Ah, interesting.
So that's a big one. Yeah, you get a USB cellular modem or a cellular modem with an Ethernet connection.
Right.
And you can connect whatever equipment you want to it. Now it's talking to the internet.
Interesting. So how do you guys decide what, like, as obviously new technologies and new standards come out, how do you guys decide which ones to detect for, which ones are maybe too early? And how often do people actually have to update their hardware in their enterprise to detect some of these new things? Or can you just a lot of times just push a software update? Or does it really depend?
Yeah, those are all great questions. So the what we build next, that's not too hard to figure out. We've got customers who ask us, they say, we've got XYZ devices deployed.
Okay.
We think this protocol is on it. Can you help us get that visibility? We've certainly had lots of customers come to us with a device in hand saying, please give us visibility into this.
I got you.
And we take it back into the lab. We figure out what protocol it is if it's not obvious. In some cases, it's a proprietary protocol, and we have to reverse engineer it and build a decoder for it from scratch without any documentation.
That probably takes a while. Or can.
Yeah, I mean, it can vary. I mean, that is a really difficult skill to cultivate, but we've got some people who are really good at that.
Interesting.
Because you're having to reverse engineer things like the coding scheme and the whitening codes. There's all kinds of subtle things that you've got to know might be possibilities and go interpret. As far as updates, so one of the beauties of using a software-defined radio is that it's software-defined. I was mentioning that Bluetooth chip. That Bluetooth chip not only is it only going to see one channel, but it's only ever going to do Bluetooth.
Right.
Because the circuits inside the ASIC are configured to only decode Bluetooth. So if you want to decode a new protocol, you're going to definitely have to buy new hardware. Similarly with your phone, if you've got a 4G phone, it's only ever going to do LTE. It's not going to do 5G because it's not a software-defined chip. But if you have a software-defined radio, when new protocols come out, you can reconfigure the decoding pipeline for whatever protocol you want. So for us, when new protocols come out, we're just pushing new firmware packages to our customers.
Yeah, that's awesome. That's really great, actually.
Yeah, they really like that because they are used to, for Wi-Fi access points, for instance, having to rip and replace them every couple of years.
Sure.
So not having to do that for your RF security system is pretty nice.
Sure.
And it means it's, it's not as expensive as it could be.
Right. So do you guys kind of have like a starting price, or does it really depend, or how do you guys kind of price this thing?
We do have pricing. I think I'll leave that for the audience that's interested to reach out to me, and I can connect you
Sure.
with our pricing people. But yeah, so for a big enterprise deployment, you tell us the size of your space, and we'll give you a number of sensors you need and give you a quote. For the flyaway kit, yeah, those are kind of just buy them off the shelf. We've got a 5 sensor flyaway kit and a 12 sensor flyaway kit. So you can have one of those for, call us up and we'll ship you one, and then you'll be on your way to putting sensors on tripods and detecting RF devices in places where you're auditing inside your facilities.
It's very cool. So how do you guys decide, and I think I know the answer to this, but like your product roadmap versus what your customers are requesting? Is it a bit of both? Do you try to just, well, I guess, yeah, like how do you define your product roadmap? Are you guys building in, like coming up with that on your own, and or getting requests from your customers, or how does that kind of work?
Yeah, it's a great question. It's a hard one in any startup, right?
Yeah.
So once we started shipping product a couple of years ago, it was easier because we had all this tangible feedback from customers. So some of them are software changes. We want to be able to support this sort of integration. And some of them were form factor changes. So we built this portable version of our system because a customer said, it'd be great if I had a portable version of the system.
Right.
Yeah, lots of feedback. I'm not sure there's a hard and fast rule. There's a little bit of an art to weighing what the customer wants. And sometimes they've engineered a solution for you, and you've got to go back and figure out what's the actual pain they're trying to solve. And is the engineered solution they've imagined the best way to do it, or is there a more sleek way for us to do it in using our infrastructure?
Sure. Well, and then too, like you have hardware and software playing together, right? And so
Yes.
Sometimes there's hardware limitations, sometimes there's software, sometimes there's both. And so managing all that must be tricky in itself sometimes.
Yeah, no, it's a huge challenge. I mean, I think it's been very difficult to build software and hardware and do this really hard RF thing. I think most products end up being really deterministic because the inputs and outputs are well defined. When you start building a RF system like we've built, the inputs are noisy and poorly defined, and we're trying to localize, or we're localizing devices, and that ends up being really hard science there too. So we've got the hardware, the software engineering of this distributed system, and then also the science of the detection. So it's been it's been really a lot of work to build what we've built. The plus side of that is there's a giant moat. So we don't really have competitors doing exactly what we're doing. And I think part of the reason is it's so hard. There's kind of a multi-miracle startup here to do the hardware and the science and get the software right.
So then are you guys building some of the hardware from scratch yourself and then getting that hardware manufactured? Or well, obviously you're probably using some stuff like just off the shelf, but are you guys building your own physical hardware pieces as well to go with some of that? Or how does that kind of work?
Yeah, great question. Yeah, so we've got a hardware design team. So we've designed the circuit board and put all that together. Of course, the circuit board uses off-the-shelf chips like an Intel FPGA.
Right.
But putting all that together in a working circuit board is a huge challenge. And we've had this sensor for a while now, so that challenge was a while ago, but now we're in really steady state production. But back then, yeah, so we designed the board, and then you go find contract manufacturers who can print PCBs and assemble the boards and package them up into sensors so that you can sell them. And then one of the things that we were focused on is doing everything in the US. Some of our government customers require that.
Right.
They don't require it. They certainly favor it. So all of our parts, everything's assembled in the U.S., built in the U.S., everything's designed in the U.S. So that gives the federal customers kind of the feel good that they're not going to have some covert implant from another country in their devices.
Well, and I think to the average person, that sounds a bit crazy, but that's actually like a real thing that and I'm sure it's pretty rare still, but I have read, if you buy even a charging cable from eBay or some third-party seller that's not authorized by Apple or whoever, you don't know what's in that cable, right? Every time you plug that in your computer, you could be sending data back. Chances are you're probably fine, but if you're the military, you want that chance to be basically zero, if not zero.
No, yeah, I don't think it's crazy at all. It's maybe I'm closer to that space, but there was a Wired article from a year or two ago where they found, I think it was just in consumer circuit boards that are in lots of computers.
Totally.
There was this unknown chip that could have exfiltrated things. So when you start talking about nation state kind of capabilities, it's not crazy at all to think that a bad actor might engineer a component into your system to compromise it. And certainly the federal government's aware of that. They call it supply chain security. It's a huge area of concern that they pay attention to really closely. So yeah, if you're close to this space, supply chain security is a big one.
No, that makes total sense. So we're kind of coming to the end of the show. So how about we close with mentioning where people can get more information about Bastille and any other links you want to mention?
Sure. So our website's bastille.net. And if you want to kind of geek out on the tech, we've got lots of instructional videos. We've got an RF 101 series and a series on all these RF attacks. And then in the last few months, we put out a half dozen webinars covering IoT attacks and Bluetooth attacks and different mechanisms to survey RF spaces, from handheld devices to bigger enterprise systems like Bastille. So there's tons of content on the website if you want to learn more. And then if you want to reach out to me, if you're interested in buying a system or learning more, feel free. I'm at bob@bastille.net, and I'll get back to you ASAP.
Perfect, Bob. Well, I really appreciate you taking the time out of your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day, man.
This is great. Thanks, Kevin. Thanks for having me.
Thank you. Okay, bye.
Thanks for listening. Please visit our website at buildingthefutureshow.com to join the free community, sign up for our newsletter, or to sponsor the show. The music is done by Electric Mantra. You can check him out at electricmantra.com, and keep building the future.